Today we're going to be looking at the concept of factoring an expression. Writing a numerical expression or algebraic expression as a product of factors is called factoring the expression. You can use the distributive property to factor expressions. So if you look at the example for numbers, you have 3 times 7 plus 3 times 2. Factoring the expression means you put it together. Whereas the last time we did it yesterday, we were actually given the 3 in the parentheses, outside of the parentheses, and 7 plus 2 and how to make it longer. This time, we're doing the opposite. They will give us a longer expression, and you have to factor it, which means eliminate common numbers or break them down. Okay, so let's take a look at factoring a numerical expression in example 1. The study tip: when you factor an expression, and those are the words they'll use, factor a numerical expression or factor an expression, you can factor out any common factors. So let's take a look. It says we're factoring 20 minus 12 using the greatest common factor. So to find the GCF of 20 and 12 by listing their factors. The easiest way to figure out factors, you may have your own way, but at this point perhaps the easiest way, especially when you're working with low numbers, is to write the factors of 20 and the factors of 12. When you're listing 20, as soon as you get to 20, you can stop. And factors of 12, once you get to 12, you can stop. So in this case, the greatest common factor of both numbers is 4. Then you're going to write each term of the expression as a product of the greatest common factor and the remaining factor. Then use the distributive factor to factor the expression. A lot of words to say. Take your original problem, 20 times or minus 12, and that will equal, 4 times 5 is 20. Minus 4 times 3 is 12. Notice we're using the greatest common factor of 4. Now we can take that longer expression and break it down into the distributive property and move those parentheses and eliminate some numbers. So now you have 4 on the outside, 5 minus 3 in the parentheses. This is one of those things you just do step by step. I'm going to have you do an example. The example I'm giving you is please factor 20 plus 8 using the greatest common factor. When you're done, come back and I'll give you the answer. Take a look at the sidebar that I have set up. You should have factored out 20. You should have factored out 8. And the common denominator, the common factor is 4. Your next step would have been to write the longer expression. 4 times 5 is 20, 4 times 2 is 8, and then take it down to factoring the expression into the smaller area. Looking at example 2, the question is, which expression is not equivalent to 16x plus 24? Well, if you look at all of these, it looks pretty complicated, and you're thinking you have to figure out each one, which is not true. It says each choice is a product of 2 factors, in which one is a whole number, and the other is the sum of 2 terms. So here you go. Sum of 2 terms, whole number. For each expression, for an expression to be equivalent to 16x plus 24, its whole number factor must be a common factor of both 16 and 24. So this is pretty easy. You would take, if you want to know the answer to this problem, you would take the factors of 16, the factors of 24. Okay? Got those blues. Now, the common factors of 16 and 24 are 1, 2, 4, and 8. Those are the common factors. Because 6 is not a common factor of 16 and 24, choice C cannot be equivalent because it has a 6 in it. It cannot. Now, you only have to figure out the other ones. So now you have Sorry. Now you can figure it out with common factors from there. Okay? You've got 2 Okay, so sorry about that. You've got now I drew a blank. Hold on just a sec. Someone's walking. Okay, so your easy answer out of here is C, because the question is which expression is not equivalent. The other ones could possibly be equivalent to all of them because they have the actual factors of 16 and 24. So those are all possibilities. C is not a possibility because it uses a number that is not a factor. So you can automatically take that out. All right. Here is your next problem. It is 15x plus 35 equivalent to 5 parentheses 3x plus 7 parentheses. Is 15x plus 35 equivalent to 5 times 3x plus 7? Yes or no? And explain your answer. Come back when you're done. Okay, the answer to the problem is yes. And here's what we have right here. Oops, sorry, I moved the wrong thing. If you do 5 times 3x plus 7, and you take that and do the distributive property, you have 5 times 3x plus 5 times 7. So you've opened it up. Now, if you figure out both those parts, you will come out with 15 plus 35. So the original question is 5x plus 35 equal to this. The answer is yes, because you can break it down to that problem. Okay, we're going to do example 3. This one's a little trickier than the other ones. You receive a discount on each book you buy for your electronic reader. The original price of each book is X dollars, so each one's going to be different. You buy 5 books for a total of 5X minus $15. Factor the expression. What can you conclude about the discount? Now the discount is the 15. Okay? The discount is the $15. So you would do 5x and 15, do the prime factorization of those numbers. Okay? So then you go down and you take those numbers, knowing that 5 is the greatest common factor because you just did a prime factorization. And the 5x times 15 will become 5 times x and 5 times 3. Then right below that, you will put it in the distributive property, which is 5x minus 3. Okay? So, here's your answer. The factor f represents the number of books you purchased. The factor x minus 3 represents the price of each book. This factor is a difference of 2 terms, showing that the price x of each book is decreased by $3. So what we figured out is, this is how many books you're going to buy. For every book you buy, you can take $3 off. Okay? It shows a $3 discount for every book you buy. The original expression shows a total of savings of $15 total. We were breaking it down to see how much you'd get off for every book. All right, I want you to try this on your own. Here's your sample problem. Pause and come back. Okay, let's take a look at it. First of all, you had to do the prime factorization. Okay, you have 1 and 3 and 2 and 3 for 3x and 6. So your greatest common factor is 3. So now we're going to take that problem, 3x minus 6, and we're going to do 3 times x and 3 times 2. In the beginning, we already know that 3 songs, at whatever price they are, you can minus $6 off of them for your discount. Okay? So don't forget that part of it. Now we're breaking it down. Now you're going to use the distributive property. 3x minus 6. What did we find out? We found out that the savings will be $6 for every 3 songs you purchase. Okay, I said that wrong. I knew it didn't look right. Okay, so $6 you save for 3 books. So we break that down now, and we have 3 times x, and then 3 times 2. Here's your distributive property. So now we can say the saving, oh, no, that's not what I wanted to do. Okay, the savings will be a discount of $2 for every song you purchase. For 3 of them, it would have been $6. Now each one is $2 savings each. All right? Little confusing. Use the example if you need to when you're doing factoring an algebraic expression. Your assignment is page 141, numbers 1 through 20, and you can check your answers in the book.